I'm Rudy Lauwereins. Maybe first a sound check. Everything okay?
Yes.
Okay, and you see my screen?
Also, yep.
Okay, perfect. I'm an engineer, so I don't trust technology at all. I was full professor at the University of Leuven till 2001, and then I moved to IMEC. IMEC is in fact a spin-off out of the University of Leuven. There I became a vice president for R&D. But I'm still teaching at the university, just one course, but I want to keep the contact with the students. And as I said already, I'm an engineer, so I'm not really involved in educational aspects. However, we do work very closely together with the team of Frederick, and in that sense, I'm really very much connected to the educational technologies. I assume that most of you don't know IMEC. It's a non-for-profit organization with around 4,500 people working there. So it's not a very small one. But the advantage of being a non-for-profit organization is that all the money we earn through collaboration with industry, we can, for 100%, invest back into the research we are doing. The main bread and butter of IMEC is semiconductor technology. We drive the semiconductor technology scaling roadmap. So we develop the recipes that are used to create the chips that are in all your electronics devices. And
Rudy,
in that sense...
Rudy, can I just interrupt? Are you showing other slides than the first one now?
No, I'm still at the first slide.
Ah, okay, sorry.
Yeah. Don't worry. So we develop the recipes necessary to build the chips. And we do that together with industry. So whatever piece of electronics you have in your hands, there is IMEC technology in it, for sure, because we do work with everyone active in the semiconductor arena. So that's why our mission doesn't tell anything about educational technology on itself, but it says IMEC aims to be the world-leading R&D and innovation hub in nanoelectronics and digital technology. A few years ago, it was only in nanoelectronics, so we expanded, and I will explain you why we did this expansion. So what are the main assets that we have at IMEC? Why companies come to us? And in fact, it's pretty similar to what Frederick already was telling us, the assets of the ITech research unit. It's infrastructure, it's people, and it's the connections with the companies. Naturally, the type of infrastructure we have is a little bit different from an educational environment. We do have a clean room, or we have a few clean rooms, and that's a total investment of around 2.5 billion euro. That's a substantial amount of money, and that's why most of those companies come to us. Even the market leader in semiconductor technology, Intel, cannot spend that amount of money as a playground for their researchers to just play around and develop new technologies. Our most expensive piece of equipment is around 150 million euro and lasts for 6 months. Then it's outdated. It has to be replaced by a new one. So no company worldwide can invest that amount of money year after year just as a playground for their researchers to develop new stuff. And that's why all the different companies come together to a single place where they all put money on the table. And with that money, we equip this kind of clean room facility. Now, it's not just renting this facility to the companies. Rent is a very, very small part of it. It's maybe 5% of what we do. But we do the developments in the clean room ourselves. And we act as a kind of translation from university research to industrial uptake. We consider ourselves as sitting in the middle between university and industry. And you see that shown by the number of people that we have. Out of the total today, 4,500 people, 900 are PhD students. So this is the amount of students working on the more fundamental and strategic basic research. On the other hand, we have roughly the same amount of industrial residents. They are on the payroll of our customers. They work for that customer company and they are sent to our location for 2 years, 3 years, 5 years, and work together with our people in the same meetings. They jointly develop together with the PhD students and with our staff people the technologies that we are developing. So in this sense, it's not like we first do research and afterwards, when that is finished, we transfer it to industry. It's co-development by the researchers and by the industrial people. In total, we have a revenue of around 680 million euro, and very unique for our research organization is that 70% of that amount of money comes directly from companies paying. It's not like European projects where you cooperate with companies, but the money comes from the government. In this case, the money comes directly from the industry. We do have European projects, that's around 10% of our revenue. And we get a grant from the local government also, mainly to support the fundamental research, the longer term research, where companies don't pay for yet. The fact that 70% of our income comes directly from companies means that those companies want results they can use. It's not free research, let's say, that they sponsor because of interest and it might be useful in the future. It's because they really need it and it's critical in their current business. That's also the reason why we run our operations as if we were a company. We call ourselves a research company. As you see, for example, with the clean room, we run 24/7. That's quite unique as a research organization to have full continuous operation. And still, we publish a lot. So it doesn't mean that working with companies prevents us from publishing and prevents us from doing advanced research. We are in Belgium ranked as the second highest patent producer, for example. So we publish, we file patents, we cooperate with companies, and we have even seen that it's easier to publish when you really collaborate with the companies, because what you do is really what makes sense, what creates impact in society, which is really needed. So the constraints within we work are not artificial constraints, but are real world constraints, which are often even more difficult. Global partnership. We work naturally together with all the companies that have a semiconductor fabrication facility. But we also work with the who is who has no fabrication facility, but are making the designs. For example, also Apple, but we are not allowed to mention that on the slides, but also with them, that's a big customer for us, because they want to know how will the process technology, how will the semiconductor technology look like in 6 to 8 years from now? The design of a new processor takes 6 to 8 years. So they want to know 4 generations ahead of time what the process technology features will be. And that's why they collaborate with us. We also collaborate with everyone building equipment that goes into clean rooms, and with everyone creating the materials that are used within a clean room. And more recently, we also work with end customers. For example, you see here the logo of Johnson & Johnson. That's a pharma company. What the hell is a pharma company doing at a semiconductor house? And in fact, it's not only Johnson & Johnson. This list of logos is only a small subset. We work with around 700 companies at the same time. All the companies that are making the vaccines today that are so hot and in the news every day, well, they all are our customers. And the reason is that, for example, for the fabrication of those vaccines, they need equipment, and this equipment is more and more relying on semiconductor technology and on artificial intelligence, for example. And we do work together with them on this. So IMEC considers itself as the bridge between universities, industry, and also government. And we have 4 strategic guidelines. Everything that's within those 4 fits within at least one of those 4 strategic guidelines is done by IMEC or can be done by IMEC. If it falls outside those 4, we will not do it. That's the way how we focus our research. And those 4 are, the first is, we want to develop the new recipes for the future for the semiconductor. That's obvious, that's how we started. But more recently, we also connect to the application environment. And why is that? Well, a long time ago, there was just one recipe to build chips. And we often compare that with a river. You have one river, but when you come close to the sea, suddenly you have the delta. And now the semiconductor technology scaling is coming close to the end of the possibilities for scaling, because we are currently working at atomic level. We work with 1, 2, 3 atom layers thick in many cases. So scaling beyond that will become difficult. And what we see today is that we have this delta coming along. The semiconductor technology in your smartphone is different from the semiconductor technology in your laptop, because the properties of these devices are different. One should be extremely power efficient. The other one has much more power, and hence we can develop the recipes in a different way. Now, for our technologists who develop these new recipes, they need to know what exactly the requirements are from these different disciplines, also from the pharma industry. They need to know when they want to develop a new DNA sequencing tool, for example, what are the exact properties they want. And one of the properties is, it's not just about computation, semiconductor technology, processors, computation, that's obvious. But in this case, they need microfluidics, for example. They want blood to be pumped around on the chip that contains the microprocessor. And hence, it's very important that we are active in as many of the application areas as possible. And the only way to do that is in conjunction with the industry, in order to make sure that we develop the right things. So we have around 8 domains in which we work together with industry, including smart education. The third one is, if it's really disruptive, we will do it. At least when there is some kind of link to electronics or software. And the fourth one is, we want to have local impact. We are paid by the Flemish government for 20% of our revenue. In return, we need to do something to the taxpayer, naturally. So we have lots of projects where we have substantial local impact. And for example, also the smart education work that we are doing at IMEC has an impact on education locally in Flanders, and hence is very much supported by IMEC. Where are we internationally? Well, the headquarters is in Belgium, but we have research entities in California, in Berkeley, in Orlando, Florida, two rather big ones in the Netherlands, in Eindhoven around 150 people, and in Wageningen also around 150 people. And then we have a smaller entity in Hsinchu, Taiwan. The other locations that are mentioned here are sales offices. Within Belgium, within Flanders, we have offices at many different locations, including in Kortrijk, where Frederik is located. And for us, Kortrijk is our main hub for the smart education part. Whereas, for example, Antwerp is our main hub for the work that we do on smart cities, and so on. The research of IMEC in just one slide. Originally, this was IMEC, this bottom part. That's the hardcore semiconductor technology. Since 2016, with the merger of another research institute in Flanders, we added to that more the software and social legal skills. For example, one of the questions that was asked to Frederik is about the privacy and security. Well, we do have a unit there together with the University of Leuven, but also with the other Flemish universities specialized in privacy and security aspects. We also have large groups working on artificial intelligence and other software techniques, and also on networking. For us, those two parts are the enabling technologies that enable applications, both from the hardware point of view, as well as from the software and social point of view. And then we have those 8 different application domains that in fact drive the research and define the specifications for the research in this enabling technology. And on the other hand, the advanced results that we get in these enabling technologies allow us in the application domains to do things that are quite disruptive. And I'll give you 3 small domains in which we are active, just some flavors of it. And the first one is in the healthcare sector. This is typically something we do with international companies, including the companies in Belgium, but also with companies really worldwide. One example, this machine is a DNA sequencer. It was developed by Pacific Biosciences, one of the leading companies in this field, located in California. And they came to us because their machine was too expensive, too bulky, too slow. And they asked if we were able to replace a large part of what goes into the machine by just silicon. And that large part that goes into the machine is not only computational stuff, that's a small fraction, but it's mostly pumps and valves and pipes and everything. And indeed, we developed this on a single chip. So we implemented pumps and pipes and mixers and chemical treatment parts and sensors and name it on a single chip. And as a result, the thing became much, much smaller. You don't clearly see it because you don't have the reference of the people standing next to the previous machine. But the new machine is 3 times smaller, 7 times faster, 2 times lower cost. The moment that this was announced internationally, Pacific Biosciences, who was the second larger DNA sequencing provider, the shares of that company immediately jumped up. And guess what? 5 minutes later, we had the people from the biggest company, Illumina, on the line, asking them if we could do the same trick. And that was possible because each of these companies works with a different basic mechanism inside the machine and hence they all use pumps and valves and so on, but the way they use them is completely different. So we could work with each of those companies. At this moment, we work with the 5 major players in DNA sequencing, and we reuse our pumps and valves and everything, and optical stuff and computational stuff. We reuse that for the completely different techniques of all 5, and can give each of them exclusivity. Naturally, not on a pump itself, but on the way how you use these pumps. And that's in fact the business model that we are using. We expect that this kind of DNA sequencing tools will become that small in the near future. And we link them with the big cloud where all the analysis will be done. And that way we expect that, and I'll put everything immediately on the slide, we expect that we can work together with hospitals, revalidation centers, doctor cabinets, pharma companies, with a whole ecosystem, like the ecosystem in the semiconductor technology, in order to advance the production of drugs and vaccines and name it. That's in short what I wanted to present for the healthcare domain. And then quickly, something that's quite different. That's the smart city work. There, we are not working with whoever is active in this domain worldwide. This is mostly in order to support the Flemish community. And in the city of Antwerp and surroundings, this is not really the city, we equipped the postal vans with additional sensors that we develop in our clean room for air pollution monitoring. And these little vans, they come everywhere. And we developed very cheap sensors that are not that accurate as the very expensive sensors that are normally used for pollution monitoring, often in the range of 100,000 euro. But with that range, you can't equip all the postal vans with such a sensor. But these postal vans pass by these expensive sensors and are calibrated each time they pass by such a sensor. And that way we get very accurate measurements also with the very cheap sensors that we are developing. And that way, by combining this with artificial intelligence, taking into account weather forecasts, taking into account actual measurements of traffic and so on, we can predict in every street in the city over a longer period of time what the pollution will be. And that helps local governments, for example, to understand the impact of changing the way they handle the traffic, closing down streets, and what will be the new traffic routes that will be taken. Similarly, we also do this for measuring the water quality. So again, you see here the map of Flanders and the measuring points where we deployed very advanced sensors to measure water quality, including the artificial intelligence analysis systems and dashboards to figure out what's happening. If there is a pollution at some place, they can predict how fast that pollution will progress to other cities and take precautions, for example. Now, smart education is in a sense similar to this smart city work, because there our main emphasis is on local impact and supporting the local community. But it also has properties of the healthcare part, in a sense that we do work together with international companies, mostly European companies in this sense, in order to develop and to deploy the educational technology. We have a kind of circle that we go through. We have the strategic basic research where, for example, Frederik is very much involved in, together with his team, to do analytics and effectiveness research, specifically on adaptive learning and personalized learning. To that, we add the technology development, both hardware as well as software, that's being done within IMEC Central. And for example, Frederik referred already to this stress monitoring and to, we call it the chill band. It's a watch that actually measures heart rate variability, your sweating, galvanic skin response, and so on. We also developed EEG systems that can be applied. We also developed the basic software tools for that, and by combining the two, we can advance, in fact, this educational technology tooling, which is then tested out in various settings. In vitro, in the labs, you have seen the labs of Frederik, in living labs, also in mobile labs like this data bus, with which we can drive to the schools and put them on the playground of the school, or have the students follow courses within this bus, where the bus is equipped with lots of technology stuff. And we also do it in vivo in the school rooms themselves, but naturally that's a less controlled environment. So we do the tests from very controlled environments up to uncontrolled environments. And the main goal for all of that is to have impact in economy and in society. So both in the companies that are selling educational technology tools, as well as in the schools that are using those educational technology tools. We do this together with the companies in projects that are strategic basic research projects and close to market, with researchers involved, as well as the people from the educational technology, and with the schools involved in order to test those new technologies out immediately. We also have, and we fund those that are projects that come up bottom up from schools, where somebody a teacher in a school says, if I would have this kind of technology, that would be much, much better. And we have seen many of these projects, one, for example, for education of how students should behave when they bike in real traffic. Naturally, you can't mimic dangerous situations in real life, but you can do that with virtual reality, for example. So they developed a virtual reality scene environment where students can bike in this environment and encounter very dangerous situations and are guided to how to handle these situations. And we also have a project called iLearn. It's a relatively large project. 20 million euro is invested in this from the Flemish government. And this is to ensure that commercial educational technology is introduced in all the Flemish schools, and that the teachers know how to use this educational technology in the schools. We also have support for startup companies in the educational technology domain. And we have our own IMEC Academy and an affiliated lab that is actually doing teaching to industry and also to schools. So this slide shows you again the lab equipment that is available to test out this educational technology in the Kortrijk environment that Frederik was mentioning. And then the last thing that I want to mention is the iLearn project that started in 2019, September. We are currently running pilots in 12 schools, and from the next academic year, we will scale up to 100 to 200 schools and hope to reach 400 or 500 schools, which is 10% of all the Flemish schools in 2022, in fact. There are two parts in it. One part is making available a whole bunch of commercially available educational technology tools from within one portal environment that also captures the data across the different tools, and where learning paths are available, adaptive for every different student. So when you want to teach something to a whole class, some people need this way of teaching, others need another way of teaching, and that is possible. So the different students in the same class can follow different learning paths supported by this environment and use, hence, different commercial tools. But there is a second part, and that is as important, if not more important, than making the tools available, and that is to help the teachers in using those tools and to set up these individual learning paths for their different students. We do that in classroom settings where we teach the teachers, but we also do that by having coaches going to the classes of the teachers themselves and helping them on the spot with these kind of systems. I had a video available for this, but I suddenly found out that this video is in Dutch, so I'm afraid that you wouldn't see much of what was being presented, so I will skip this video now, and hence I will conclude this presentation. Thank you so much.
Thank you very much, Rudy, for sharing that story and starting from semiconductors, ending up with smart education. It's a very interesting way of presenting the research that is going on in IMEC. We are running out of time, but maybe there is one urgent question from the audience about what you just told. I don't see hands raised. I do have one particular question, Rudy. You talked about the co-development of researchers and people from companies working in IMEC. I was just wondering, how unique is that model all over the world? In any idea? Is that copied in other the research centers, you know, or is that quite unique in the rest of the world?
As far as we know, it's quite unique. I'm not saying that it's in no other places copied, because, for example, CEALETI in Grenoble in France has a kind of similar model, although they work more with licensing of patents instead of joint research. But still, it's quite unique. And in many cases, one of the unique aspects is you have competitors working side by side on development of new things. And in several cases, those companies meet each other at IMEC working together. And the other places where they meet is literally in court, where they fight against each other. Apple and Samsung, for example, they meet at two places, at IMEC to develop the new smartphones, let's say, and in court to fight against patent issues.
Okay, that's a very nice one to end.
Definitely, the way that we are within IMEC is regarding security. It's an important thing of our life. Printing something to a printer, nothing comes out of the printer until you go physically to the printer and use your badge and so on, just to avoid that while Apple sends the design of their new smartphone to the printer, that the guy of Samsung is waiting at the printer to just have a quick look at what's coming out of this.
Yeah. Okay.
Also, network security is taken really seriously.
I can imagine. Yeah. Okay. I've seen in the chat that both Milena and Wouter mentioned a couple of links on the EETN website to things that you mentioned, Rudy, and that we already talked about on the EETN website, for instance, about the iLearn project, about smart education, and so on.
I think that there's also one quick question from Alberto.
Sorry.
Yep. Hi, everyone. My name is Alberto, and I wanted to ask Rudy about the relationship IMEC has with different innovation ecosystems, for example, in Silicon Valley or in Israel, if there's any.
There definitely is collaboration. With Israel is a little bit less, I think. We do have collaboration in Israel, mostly on the security aspects, cryptography and so on. With Silicon Valley being a silicon company, we do have collaborations naturally. And it's sometimes funny to see that companies based in Silicon Valley ask us to make the designs of their new silicon. It's fun. We also have a very close relationship with the Silicon Europe Alliance, the alliance of companies within Europe on silicon design, also with SEMI, which is a worldwide company of a worldwide network of companies that develop equipment for clean rooms, for semiconductor clean rooms and so on. So we definitely do work together. And now I only looked at the semiconductor field because you were asking specifically about the Silicon Valley, but also in other fields, we have this kind of collaborations. For example, we have a very, very strong collaboration with Johns Hopkins University in the USA for clinical trials. And also in Europe, we have lots of collaborations, also in the UK, for clinical trials with the devices that we are developing.